Good afternoon, everyone. Thank you for joining us. My name is Marissa Waterman, and I'm the Marketing Director here at the Academy. Today's event will feature 4 topics in under an hour. Our Executive Director, Dr. Daniel Other, will serve as the moderator and will introduce our speakers today. During each presentation, you'll be able to submit a question by clicking on the Q&A icon on the bottom of your screen. Before we get started, Dr. Other would like to say a few words. Dan, how are you?
All right. Well, welcome, everybody. Thank you, Marissa. I want to start off by saying thanks to the patrons of the Academy. Without your financial support, we wouldn't be able to do a lot of the things that we do. So patrons of the Academy, utilities, firms who financially support our activities, we are so grateful for you and all you do to support us. Marissa, as you and others know, the 5-year goal of the Academy is to grow, connect, and diversify our profession by sharing stories. And that's what today is all about. We're going to share some stories from some exceptional environmental engineers and scientists, and this is going to just be inspiring to all of us. I'd like to say thanks and welcome to our 4 speakers. These include Cecilia Dominguez, Yang, Colleen Naughton, and Aaron Bivens. Aaron and I will be speaking about board certification. What we're going to do today is called PechaKucha. I know when you see this word, a lot of people want to say PechaKucha, but that's not it. It's actually pronounced PechaKucha. It's actually a Japanese word, and if we were going to translate it to English, it would sound like chit-chat. PechaKuchas are a celebration of people, passion, and creative thought, and it's a particular format. It's an art form. Presenters give 20 slides. Each slide is up for 20 seconds. So a PechaKucha is this unique art form that allows people to present something that they're very passionate about in a very bite-sized or chunky nugget. So it's 6 minutes and 40 seconds of people's most passionate thoughts. Today we have 4 different speakers. Cecilia Dominguez, who's going to be speaking with us about biosolids in a large wastewater treatment facility in Los Angeles County. Yang, who's going to be speaking with us about how to destroy PFAS in water and soil. Colleen Naughton, who's going to be talking about the food, energy, water nexus, particularly for underserved populations. And then, as I mentioned at the beginning, Aaron Bivens, who, congratulations, Aaron, on recently becoming a board-certified environmental engineer, will be having a conversation with me on what it means to become board-certified. So today, we are really excited to have these 4 speakers. We're grateful for our patrons, for their financial support, and I'd like to go ahead and get us started. Cecilia, you'll be up first. All right, Cecilia Dominguez is an operations engineer at Los Angeles County Sanitation District. She's a member of the Academy, and Cecilia has her professional engineering license. Cecilia, the stage is yours, and we'll get your slides started. And remember, 20 seconds each.
Yes, hi. So first, I'm going to provide some background on the AKA Warren Water Resource Facility, formerly known as the Joint Water Pollution Control Plant. I'll take you on the pathway that biosolids take through the plant, what ongoing operations at solids processing entails, and then I'll wrap it up with some of the benefits of biosolids reuse. First, make sure everyone's on the same page. In wastewater treatment, liquids are separated from the solids, treated physically and biologically to produce a semi-solid, nutrient-rich product we call biosolids or cake. Biosolids are most popularly used as compost or natural fertilizer, but can also be converted to a biogas to be used for heat, power, or vehicle fuel, which is what we do at our power plant. This map shows location of the district's wastewater treatment facilities. The Warren facility is a key component of a network of 7 treatment plants and over 1,400 miles of trunk sewers. 6 upstream water reclamation plants in the joint outfall system produce recycled water, and then the solids from those plants are all sent to us at Warren. We have an aerial view of the facility here. It's the district's oldest and largest wastewater treatment facility. We serve a population of approximately 3.5 million people, for wastewater that is, while we process solids for 5 million people. Solids are collected in primary and secondary treatment, processed in anaerobic digesters, and then the methane gas is used to produce power and digester heating steam in our power plant. In fact, the on-site generation of electricity allows us to run entirely on our own power. The solids that, or the wastewater that comes in comes through 3 inlet sewers, past bar screens, sedimentation tanks, and then solids are collected from primary and secondary treatment. In solids processing, we are dewatering using centrifuges, and then biosolids are conveyed onto a series of belts, make their way to storage silos, and then conveyed onto truck loading stations before they're hauled away. You have a view above ground of our digesters. 15 feet are above the street, but at their highest depth, 50 feet, 125 in diameter, and we have 24 of these on site. In addition to raw and waste activated sludge, we take in a small amount from food waste. We use mesophilic organisms, making these Class B biosolids. And here you'll see inside of a digester, because when you work in operations, you get to go inside of the digesters when they're cleaned, of course. An anaerobic digestion, like I mentioned before, reduces quantity of pathogens, stabilizes solids, improving dewatering, and creates methane gas that we can run all of our own power. Yes, we quite literally run on biosolids. The sludge after digestion is pumped over to our screenings building. This screening improves centrifuge performance downstream and the quality of the dewatered biosolids. As the final step, we have 20 centrifuges that are used for solids dewatering, 18 of which are high-speed scroll centrifuges. These utilize centrifugal force from a rotating steel bowl to increase gravitational forces to separate the suspended solids from water. Centrifuges capture 95 to 97% of the solids in the sludge, but that clarified liquid is sent to our centrate treatment system facility operating as a DAF. We're able to increase recovery of the solids to 99%. The solids, after they've been dewatered, are conveyed by a series of belts to our biosolid storage silos. We have 18 of them on site. Typically, we produce about 1,200 wet tons of biosolids per day. Research has determined odors increase exponentially after 24 hours. So our goal is to keep that amount in the silos at all times so that we are good neighbors in managing our odors properly. Then from the silos, they're conveyed to one of 3 available truck loading stations where operators weigh and load biosolids into hauling trucks, as shown in the bottom middle. After the biosolids are loaded onto trucks, taken off site, not my problem anymore, and we schedule 50 hauling trucks per day to maintain that 1,200 wet ton inventory in the silos. When we're looking at the benefits of biosolids, and offsite includes their nutrient content, our Warren biosolids typically are 1 to 2% nitrogen and 2 to 3% phosphorus, making them beneficial soil amendment for agriculture. Benefits include what you see here, like nutrient conservation, improved soil structure, and landfill conservation. Here's a look at our current biosolids allocation. We have 4 compost sites in blue, accounting for actually currently 57% of our biosolids, and 1 Class B land application contractor in green, accounting for 5% of our biosolids. 2 landfills accounting for 38%. When we're looking ahead at making biosolids management decisions, we're constantly evaluating new options for reliability. Will the contractor be able to pick up their loads every day? Yes, this is a problem sometimes. Long-term viability. Will the site remain open for the foreseeable future? Cost effectiveness, different options for diversification. And we look at program criteria for the from 2012 Biosolids Business Plan. I'll highlight here for a moment our Inland Empire Regional Composting Facility. We're 50% owners through a joint powers agreement with Inland Empire Utilities Agency, built in an old IKEA warehouse in Rancho Cucamonga. This shows you if you can compost in Metro LA, you can do it anywhere. And then when we're looking ahead, COVID proved to be a very turbulent time for the biosolids industry. Now that hauling and management is stabilizing, we're looking ahead. We expect that some of these challenges will continue for the foreseeable future. But to maintain performance, we'll look to diversify haulers and locations, try to enforce misload penalties, and focus on districts owned facilities. With that very brief summary, if you have any questions, please let me know.
Cecilia, that was fantastic. Congratulations. Well done on your first PechaKucha. That's a lot, isn't it?
It was fun. It's a lot, but it was fun.
Fantastic, fantastic. Well, we really appreciate you. Thanks for what you did. We had some questions that came in the chat, and I'm gonna, help kind of cover those a little bit, and then just give you an opportunity to kind of like think through. So a couple of them that came in was a few little details: size of the facility and MGD. Little details like your polymer and your additives to get to 29% solids. And then there was a question a little bit larger, kind of over the horizon, thinking about PFAS. You guys are at Class B biosolids, so thinking about PFAS and what kind of regulations are coming up and what might affect you there. So size of the facility and MGD, a little bit about the polymer, and then thoughts about, Class B, and then if any thoughts about, how PFAS might affect those in the future.
Sure. So our current capacity is 400 MGD, but our current flow coming in is 250 MGD. So that's what we're looking at.
Does that design 400 or wet capacity 400 max?
No, that's design capacity. So in a really heavy rain event like we've had, really heavy, but keep in mind that LA can't handle water infrastructure. We're able to go up to 700, 750 with the amount of redundancy that we have conveniently. But yeah, design capacity 400.
Wow,
and current flow 250.
Fantastic, thanks. And then polymer?
So we use, because for polymer. So I'll say we use alpha Laval G2s for our centrifuges, and we use a cationic polymer that's in. I don't know if they want to know amount or the specific type.
How much polymer and other additives like ferric sulfate did you use to get to 29%?
It's the cationic polymer. And so we're monitoring that based on, with every centrifuge, we send 300 gallons per minute. And with that, around 9 gallons per minute of this cationic polymer that's brought down to a 3.4% active polymer by the time it's blended with water.
Awesome, thank you. And then any thoughts on PFAS over the horizon? You're at Class B now. Any thoughts?
So I know we're participating in research along other agencies, and we're really good about trying to stay up ahead. We have a really good research team here that's trying to keep above in any regulations. I know that for PFAS, it's not something in operations level am specifically looking at. Definitely above me and our research team, that's what they're looking at. And, you can't really turn a stone without there being some mention of PFAS. So no one is devoid of it. We're participating in the research, but I'm not sure what that immediately is going to look like for change. But I guess not too many of us do, right? It's ever evolving.
Ever about Cecilia, thank you so much. Appreciate it. Thank you. Thanks for joining us. So
thank you.
Hi, welcome to our PechaKucha event today for the Academy. PechaKuchas are celebrating people's passionate topics with slides that are 20 slides, 20 seconds each to present a topic that they're passionate about. Today, we have Dr. Yang, an assistant professor at Clarkson University, and Yang's going to be speaking with us about electrifying water and soil for PFAS destruction. Yang, the stage is yours, and welcome to our PechaKuchas today.
Thank you, Dan. Thank you, everybody. The great introduction. A lot of people cares about PFAS, so I don't need to spend more words on that. So PFAS is definitely very challenging to be removed from water and soil. Today, I'm actually going to talk about a more challenging topic: the complete destruction of PFAS down to fluoride in very complicated matrix like AAAEF. So nowadays, there are several solutions that can remove certain target PFAS from AAAEF. Only hydrothermal method can achieve the complete defluorination. That means 100% conversion to fluoride. Note that this technology requires high temperature and pressure. So as of today, room temperature, the complete defluorination of AAAEF was not achieved yet. Till our investigation. So I want to talk about further improvement of electrochemical oxidation to facilitate us to achieve 100% defluorination. To start with, we first need to figure out why electrochemical oxidation cannot achieve deep defluorination of certain PFAS. We have conducted a very holistic investigation and come to a conclusion that for PFAS with a odd number of fluorocarbon, it cannot achieve deep defluorination. That inspired us to make some change by introducing a UV sulfide pretreatment to weakening the alpha carbon so that we can actually turn the odd number fluorocarbon to even number fluorocarbon PFAS, and that will lead to eventually 100% defluorination. To implement this idea, we tried that out on treatment of PFOA, PFBA, and PFOS. These compounds cannot be 100% defluorinated by EO alone, but using the tandem treatment process, we are excited to see that they are all being converted to fluoride anion. So we further implement this idea in the treating of actual AFFF. This is a quite busy figure, but I would like to have your attention focus on panel D. Regardless of this up and down of PFAS, eventually we are able to achieve 100% defluorination of AFFF and ambient conditions. We also analyze all these non-targeted PFAS precursors, and the results shows that the process can also eliminate those fluorocarbon surfactant molecules. The result is very promising. In the next slide, you can see that after the treatment process, we actually eliminate the foaming potential of AFFF. So this finding also echoes back to our conclusion that all the fluorocarbon surfactant was actually mineralized down to fluoride. So there's no other concern. And we also measured TOC, it was reduced significantly. So that inspired us to apply the principle of electrochemical oxidation to treat solid waste. However, as you can imagine, it is impossible to treat the solid waste directly by just inserting electrode into the soil. We have to develop a new treatment paradigm. So we propose that we can use piezoelectric mineral as a catalyst. So these are a group of material that upon mechanical impact, it can create transient high voltage on the surface. The voltage is high enough to even ignite to create a spark in the lightning. One example is that if we use boron nitride as an example, and deformation at micrometer level can create thousands of piezoelectric voltage. That is more than enough to completely destroy PFAS. So this slide shows a theoretical modeling. The result further convinced me that if we grind boron nitride with PFAS in a ball mill, the ball collision between all these within this mechanochemical process can create a transient high potential up to 3,000 volts. So we implement this idea in the destruction of PFOA and PFOS. Obviously, the parent compound was completely destroyed, and we are also very excited to see that for the first time we achieve 100% defluorination of this compound at ambient condition. That means without heating, without pressurization. And we further apply these technology in treating sediments impacted by AFFF. The results shows that regardless of the structure of the PFAS, a majority of them gets removed after 6 hours of ball milling. And we are working on upscaling this process. This slide shows our most recent study. We try to use this technology to treat undiluted liquid AFFF. The result is also very promising. We're able to achieve 100% defluorination of undiluted AFFF, still at ambient condition, without temperature rising, without pressurization. So can we scale up those electrochemical oxidation or ball milling process? I think the answer is quite positive because boron doped diamond electrode has been widely used as a commercial product in industrial wastewater treatment. So there will be an argument about cost and benefit. I think this is the one to be discussed. And people also curious about, can I upscale those tiny jars into big jars? The answer is also yes, because the ball mill is actually an existing industrial equipment widely adopted in metallurgical industry and other applications. So the take-home message I want to deliver is that electrochemical oxidation coupling with UV sulfide pretreatment can destroy PFAS in aqueous phase, while piezoelectric ball milling can destroy PFAS in the solid phase. So PFAS are not forever chemical if you choose the right strategy. I'm merely a storyteller, so all these critical insight were contributed by my collaborator, my student. I'm very grateful for the funding agency to support us move this far and possibly go beyond. Thank you very much.
Yang, thank you so much. You survived your first PechaKucha. Well done, my friend. Really enjoyed that. Reminding folks to put their questions in the QA panel, but I just got a couple to kind of like, look at this technology. One is on the kind of the detail level. Are there inhibitors? Are there competitors for the process at the scale that you're working at? In other words, like you're trying to get rid of PFAS, they're in a small amount. There's all this other stuff out there. So what would be some of the inhibitors or the competitors for the reaction at this, kind of that you're working at with electrification in soil? So that's one question. Second is, when you try to bring this up to scale and you were already touching on it, do you have a sense for how far you can scale it up? I mean, we hear this kind of language, well, PFAS is everywhere, right? So I doubt you're going to electrify all the soil on the surface of the earth to get rid of the PFAS. So at what scale do you think this kind of technology will scale? And how does that compare to kind of other things that might be available to us? So first question, competitors, inhibitors for the process. And second, what level do you see that this could scale up to?
Thank you for those questions. I think this question actually could be incentive for multiple proposals. So first of all, inhibitor, as you can see, if you compare soil treatment versus the treatment of pure chemical, the kinetics is significantly slower for the former case. That is probably because of the competitor of organics. And also PFAS in porous structure or actual solid waste might be protected by all these structures, and which shield them from direct mechanical impact force. But I also see a promising hint in the treatment of AFFF, because the AFFF we are treating contains gram per liter level of TOC, and we are still managed to destroy all this PFAS. I guess there will be several factors having a critical role in. First of all, can they mitigate the chemical impact force? Secondly, will they compete with compete the reactive species? We don't know yet within this process. Oh, so this is a very exciting new area, and I hope that I can have a better answer in the future. And also, as for scaling up, we are working on that. So we are building a pilot scale system at 100 gallons per day treatment capacity. So we have a methodology established to reproduce the results from the lab scale to a meso scale process. That is almost complete. So we are confident that we can move it further. Again, the equipment is already there. The theory of mechanochemical impact is already there. It's in the physics textbook. All we need to do is to make sure that all these levels of energy align at a small scale with the larger scale, and then we're confident that scaling up shouldn't be a big problem.
Okay, so you're familiar that this is, that some of these kinds of approaches have been tried for other chemicals in the 80s and 90s, and so you're relying on all of that kind of literature. And how about the aqueous phase treatment? Can you speak to that work that's going on at Clarkson as well? Do you guys have some work going on the aqueous phase?
Yeah, so we are working on treatment of using bombing process to treat liquid waste, okay. And it's a bit tricky. So we have a preprint published. It turns out that the reaction kinetic is really determined by the thickness of the liquid film cover on the boron nitride and also the balls. So yeah, a model is being developed. Unfortunately, I cannot answer the question whether it can be used for treating tons of liquid waste. I hope I can have a better understanding in the next few years.
Well, Dr. Yang, thank you so much. Once again, congratulations on an excellent PechaKucha. Very well done. Thank you.
My great pleasure.
Thank you. Well, Colleen, if you want to turn yours on, I will start our little intro. We'll get going. Welcome all to the Academy's PechaKucha event. This is a celebration of people's passions where we use PechaKucha, a format that people present 20 slides in 20 seconds each. And our speaker today is Dr. Colleen Naughton. Colleen is an assistant professor at the University of California, Merced. And today she's going to be speaking with us about food, energy, water systems for the underserved. Colleen, the stage is yours and welcome.
Yeah, thank you so much and for this opportunity to present. We'll let the next slide. I don't know if we get 20 seconds on the intro slide. So food, energy, water systems are all around us. This is a photo I took actually on my interview at UC Merced in 2019. So you see transmission lines, a water tower, and almond orchards. But unfortunately, not everybody has equal access to food, energy, water systems. And there's ways that we can be, more sustainable. And my lab has a toolkit that we use with different methods for sustainable food, energy, water systems for and with the underserved, including community-based participatory research, life cycle assessment, and geographic information systems, as well as science policy. And so as environmental engineers, I think in particular, this can be a challenging part of shopping and like what's the most sustainable, eco-conscious product in addition to price. And a way that we can look at that is through life cycle assessment in addition to, you have your organic certifications and like other labeling. I think you'll have to advance these, Marissa, sorry. Link slide. But there's some, for different oil systems, for example, there's kind of natural forests like shea butter in West Africa and sub-Saharan Africa, or there could be systems like palm oil that have more deforestation. And a way to kind of quantify, product or process or a crop from cradle to grave is through life cycle assessment, and there's an ISO standard for this, and you can look at different stages of the product or process, not just the use phase. And so for starting with shea butter, we'll get to argan oil as well in Morocco and tomatoes in California, but it's a very multi-stage intensive process, mostly run by women to produce this from a fruit from a tree for heating the nuts and extracting the oil. And so to do a life cycle assessment, you have to do a life cycle inventory. So collecting everything that goes into the product or process. So we had to weigh the firewood that's used to dry the nuts and the kernels and get the different extraction rates from the fruits and the nuts. So for other crops, you look at fertilizers and pesticides, and then we can compare to other life cycle assessments of different oils. So you actually see that shea butter is pretty high for global warming potential. But if you look at more sun drying or more, cook stoves that are more efficient, that you can bring down the carbon footprint. And the palm oil carbon footprint sometimes doesn't take into account land use, so you have to watch your life cycle assessment and what stages they include. The next, going to Northern Africa through a National Science Foundation grant, is looking at women's argan oil, which is similar to shea butter production, and also an edible oil that's very popular, but also in cosmetics. And we can look at not just environmental life cycle assessment, but social life cycle assessment that also follows the same ISO guidelines as environmental, but has the United Nations Environment Program, has different stakeholder categories like workers, and we can look at society and health and human safety. So as an argan oil process is similar to shea butter with a tree nut and sort of these fruits, but it has like an almond inside, and the cracking is a lot harder than taking out the shells from the shea butter process. So I like life cycle assessment. You can learn about how different crops and products are made. So there is a roasting process, not as much to use firewood to heat the almonds for the edible oil. as well as grinding. And this is all the manual process. We've been looking at different levels of mechanization as well. And then there's a pressing process to extract the oil and then to filter it. And then we quantified through social life cycle assessment the different amounts of hours and days, and also did some human energy calculations for the different stages in the process. So to make 1 liter of argan oil takes over 24 hours, I think between 4 to 8 days, which is a lot of time. And we also looked at women's wages, and they were making less than the minimum wage, which is less than 80 cents an hour. So we also looked at injuries and pain. So you see pressing is one of the most hardest parts of argan oil, even though it was only 45 minutes or less time intensive process. Going to California, which is a 12 or 13-hour flight from Morocco area, we can look at diced tomatoes versus fresh tomatoes, and what is more sustainable right now, and the answer might surprise you. Yeah, so another big issue in food is food waste, not just the lettuce that you let go bad in your fridge, but also on the farm level food loss to get you that kind of perfect tomato. They're actually picked green, but some are left on the field if they're too small or damaged. Or just, yeah, we quantified the global warming potential, and we found tomato loss contributes a lot to CO2 that's left on the field. I mean, some is given back to the soil, but there's a lot of inputs that are put in there that aren't harvested. And it's up to 40 to 60% is lost on the field currently. And so you can see diced tomatoes actually have less global warming potential than fresh tomatoes. Because all in the diced tomato process, you don't have as much farm level food loss. And then tomato paste is still higher because of the heating processes in the industry and the canning. In food, we need to look at, the water inputs as well. We do quantify that in life cycle assessment, but also the impacts into human health and the environment. So agriculture contributes a lot of nitrates to the water through fertilizer. Also, our typical wastewater does as well, and that's been linked to thyroid cancer, particularly in women, but also men. And so we did a geospatial analysis looking at hotspots for nitrates and thyroid cancer and correlations, and found that there were in disadvantaged and underserved communities in particular, there was higher rates of thyroid cancer where there were higher rates of nitrates in wells. So overall, yeah, this is, as Yang said with his research, this is a group effort with my lab, and we really strive to have sustainable food, energy, water systems for the underserved, not just in the United States, but globally. So thank you again for this presentation. I welcome any questions.
Thank you, Colleen. Congratulations. Excellent job. Well done on your PechaKucha. We really appreciate you being here. I saw in the photo the littlest Naughton Lab member in there. So very nice. Congratulations. Congratulations. I remind folks, if you've got questions, you're welcome to put them in the QA panel, and I'll bring them in. Just two that I've got to kind of think about this. One is to discuss looking at the life cycle assessment, right? So there's the social life cycle assessment part, right? And so if you can explain a little bit more some of those kind of tools, but if you can also, if there's any information on how do we factor in the climate change or the weather variations and weather extremes that we're seeing as part of LCA, right? Because it's like what you plant and how you plant, and are you expecting it to actually make it to the end of the season, is becoming probably more variable than it may have been in the past, now and in the future. So how does social and how does climate fit into your LCA? If you can think about that a little bit. The other one is that you talked about the community-based participatory research, right? That idea of partnering with the communities. So when you partner, can you speak a little bit to kind of what the partnerships were like in Morocco versus in California, right? Are there some similarities to partnerships that translate no matter what community you're with, or do you have to kind of rework them and relearn the skills every time? So two questions kind of at the LCA, particularly the social and maybe some of the weather, climate, how does that factor in? And then the community-based, are there general community principles, or do you have to kind of rework it with each community? Colleen?
Okay, great. Yeah, some great questions. I'll try to address them in order. So first for social LC, and I know Dave has a question in the Q&A as well. It's still like developing. I think it's like 20 years or so that social LCA has been out there, but like a little less long than environmental life cycle assessment. But as you saw with the chart in my presentation, there's different like kind of stakeholder categories you choose, whether you're focusing like we a lot of times do the worker category, but you can look at society at large and also even the consumer. So as far as tools, it's relying. I like work with a lot of anthropologists or social scientists, so a lot of it's still looking at questionnaires, surveys. It's hard to like kind of put quantities to things, so that's why we looked at working hours. And then we kind of looked at, where is the hardest part based on interviewing like different households and cooperatives, or where is your like pain? You can do like kind of Likert scale ranking, but you have to adjust that, no matter in like translate it and see if it's translatable, especially if you're working in other cultures. So it's still emerging like part of, and UNEP has like methodological sheets and like there's a lot of great examples out there. But you kind of have to tailor it to each product that you're looking at and like the community and like what the needs or what you're really trying to focus in on. As far as climate, that's definitely being challenged, especially in California with the water issues or really anywhere around the world. Like, and that's part of where LCA, where we've been looking at like this big USDA grant that we've been kind of quantifying orchard crops versus more maybe perennial crops like the alfalfa has like a little shorter growing cycle than almonds or tree crops that have to be watered every year because it's they're there for 25 years. If you don't water a year, then your whole orchard like dies, as opposed to crops that are more annual or shorter growing cycles that can be followed for a while. So we're kind of quantifying those differences, and within climate change, maybe there's different crop selections that you can make. And I know that's challenging for growers that are used to growing a certain crop, but that's part of what we're trying to inform the community here of like, what crops might be appropriate given climate change. And I'm sure some of our life cycle assessments will change with if there's more waste or more inputs needed because of climate change. And then third, for community-based participatory research, like there is a lot of translatable things that are similar, no matter where you are, just about, listening first to the community, like what are the needs? That's why the tomato research came from a grower that came to us and they're like, we're seeing all this, farm level food loss on our field. Can you help us? And we don't have time. Can you help us like quantify that? And if it's, it's not worth it to us economically to harvest it right now because the labor is so expensive. But we want to see what kind of impact it is making environmentally, and maybe actually it does make economic sense now. So more just like kind of listening what the needs are. If you go to a different country, I've worked, a lot in different African countries, you do have to, it's good to, learn the language or at least the greetings, and you have to be like sensitive to different like cultural norms. So there are some differences, and even some differences I've learned. I'm from the Midwest, and working in California is, a little different. Or in Mali, it was perfectly okay to ask someone how big their field was, or like, ask some questions about their crop. And in California, if you do that, people are like, are you trying to calculate my income? They're like very offended by certain, so you kind of have to feel some things are okay somewhere and not. So you kind of just have to, you learn by doing, but yeah, do your research as well and ask around so you don't get, offend someone unintentionally.
That's brilliant insight. Thank you so much. Well, Colleen, congratulations on a fantastic PechaKucha. We are really grateful for having had you here today. Thank you so much.
Yeah, thank you.
All right. Well, I think this will be the slide. Maybe Marissa will let me do the introduction because this may start the clock. I don't know. So, hi, welcome to our PechaKucha event by the Academy, where we're sharing our stories to grow, connect, and diversify the environmental engineering and science profession. One of the things that we're going to be talking about here today is board certification. My name is Dan Other, and I'm the Executive Director of the Academy. I achieved board certification in our wastewater water supply specialty in 2005, and then via eminence in our life sciences in 2018. I am here with Professor Aaron Bivens, who has his PhD from Georgia Tech in 2019. He's been a PE in Georgia since 2012, and we're going to have a bit of a conversation back and forth. Aaron just accomplished board certification in our wastewater water specialty in 2024, and so we're going to have some opportunity to have some conversation. I'm going to ask him some questions. But let me start by thinking about what is board certification. What is it then? You shall not pass, right? So there was a little bit of what some folks might have characterized as a gatekeeper. Are you board certified or are you not? Now the Academy really has adopted this idea of a rising tide lifts all boats, a mentor of sorts. But not all boats are the same, right? There are different people along our journey. Student members, we invite them in free. And according to our bylaws, any student enrolled pursuing environmental engineering or other areas, we need you. So you're undergrad, you're grad, you're overseas, you're part-time, you're civil engineering, you're chemical engineering, we want you. What's in between student membership and board certification? Regular membership at $125 a year. The bylaws for the Academy invite individuals who hold a degree that would make them eligible for student membership, so who have graduated, and then who are working in environmental engineering and science. We want to coach those people to board certification. So what does that look like? Membership plus. So you're a licensed engineer with 8 years of experience, 4 of which are in responsible charge. You're a scientist with 8 years of experience, 4 of which are in responsible charge. If you were a grad student, you get some credit for being a grad student. If you've got more than 16 years worth of experience, you can get a waiver on the written exam. And if you've got 20 years of experience, you can apply via eminence. But there's this important phrase here. There's work experience with responsible charge. And what that means is that you're leading engineering and science, not just doing it. So here's the question to you, Aaron. Why did you seek board certification? Was it fame? Was it fortune? Was it the right thing to do? Let us know. Oh, you're on mute. We get you off mute.
I'm
There we go.
burning our time. Yeah, hi everyone. I constantly harp on my students about staying engaged and being a lifelong learner. And I really thought board certification was a great way for me to do that, to stay engaged in professional practice and bring that perspective into the classroom, which is of course where our students are hopefully headed. So that was what motivated me to pursue it.
Appreciate that. So how'd you find the process? Painful, painless, something in between? Did you study for these tests?
Yeah, so there's, always helpful staff to help you navigate the process. It was pretty painless. The written exam was remotely monitored, so that part was a bit painful because I basically cleaned out my office of any useful materials so that, I was above board on that. And I did study, not nearly as much as I originally intended, but I did study and pull out, Metcalf and Eddy and Rittman and McCarty and some of the classics. And so that was great to revisit.
Kind of fun. I know I studied. What advice would you share to PEs in the workplace, right? Like you got your PE, you were in school. So how about for faculty members, right? Like what are your advice to people who are PEs?
Yeah, I think, I would say for those of you involved in practice, we really need you engaged with the Academy, right? So for PEs, reach out to your local universities, get engaged in the work there. A lot of the problems that PEs are facing in terms of design challenges are opportunities for research and new learning. And of course, the challenges we're facing are complex now, so we need everyone on board.
And then what advice would you share for faculty, right? Folks that consider themselves like serious diehard researchers. Would you still encourage them to pursue this, and why?
Yeah, I think for me, being engaged in practice, that's where most of our students are headed. And so for me, that's a high priority. I try to center engineering practice in the classroom with my problems and examples. And so I think board certification is a great way to do that and to demonstrate earnestness about being engaged and to bring that perspective to your students so that once they actually begin their work, hopefully they're not totally lost like I was.
And Aaron, how about the scientist, right? When we're looking at this as engineers, any advice that you would share to scientists that are interested in board certification?
Yeah, so I think for scientists, this is a great opportunity to interface with engineers, PEs, academics. We really need your perspective. One of the tensions I feel as an engineering educator is how constrained our perspective is, and sewage treatment, water treatment, but of course the environment. There's ecology, and I had a chance to work with a lot of ecologists when I was a postdoc at Notre Dame, and we really need the environmental scientists to help us broaden our horizons.
Perfect. Final words of wisdom?
Yeah, this is something I'm going through in my own life. I feel like it's very, very important to make the time and space to learn new things and meet new people. It's very easy to get quite busy and siloed. I'm a newish dad with a second on the way, and so I feel this pinch. So make the time and space to learn new things and meet new people.
Thanks, Aaron. So just remember all, in summary, if you're a student member and you're enrolled as a student, sign up to be a free member of the Academy. If you've graduated and you're employed, sign up to be a member of the Academy. If you've got 8 years of experience, including 4 years in responsible charge, pursue board certification. Aaron, fantastic to chat with you. Looking at some of the questions that came in and looking at some of the things people are looking at. Okay, we're not going to comment on the pictures on our facial hair. Aaron and I grabbed some of those pictures online from social media.
Freely
Aaron
available.
Obviously yeah, we're just fun people that like to do fun things, right? Weren't we talking it's expensive to get haircuts sometimes? So, but Aaron, I tell you what, one of the things I admire about you is your passion as a engineer who's then worked in practice, who's then gone back, who's, done school, who's then, working in academia, thinking about your students. I was so struck that you have done fantastic research work with high impact, highly cited, fantastic discovery research, and you take board certification and being a professional so serious. And how have your students responded to that?
I think, honestly, students are sometimes, at least I can only speak to the environmental engineering. They're a bit lost about how what we're talking about day in and day out applies to the role they're going to be asked to play in society. And so I've found by bringing examples in that make that less mysterious and kind of front loading, hey, this is what you're going to have to think about. These are the issues you're going to have to engage with. I think it makes the education relevant. And I think it directs their attention and it motivates them. So I'm always trying to bring that perspective into the classroom to keep the students kind of on their toes and help them imagine what their future looks like.
Perfect. And have you found that some folks it resonates? It's kind of the right thing to do, right? I mean, it's like, of course you would be licensed if you could. Of course you would be board certified if you could. Do some people gravitate to that, or do folks really gravitate to the, hey, I like the real world examples, or is it kind of a mix of all of the above? Or
I think in our program it's a mix. I'm actually not sure. I mean, we have a fair amount of students that take the EIT. I'm not sure how many of them go on to the PE in environmental engineering, but I've, in my own journey, right, I remember I sat in my first design review with my supervising engineer, and she pulled out a hydraulics textbook, and I was like, oh, like that's what this class was for. And so I'm trying to prevent my students from having that experience. I'm trying to give them the hey, this is why you need this up front. And I feel like that really, the motivation is the one thing that, is key for lifelong learning. And so I really try to double down on keeping them motivated.
And you had mentioned that it was a fairly painless process and that the staff for the Academy were very supportive. We've got some fantastic staff. In terms of kind of your experience, were you able to send things in and kind of get some, not feedback as in yes, no, you'll be board certified, but if you were confused about forms or you had questions about things, and did you receive some contacts so you could kind of know what your next step was? Talk through a little bit about what your process was like.
Yeah, I was in touch with Susanna the whole way through, and that was great because there were kind of moments where I was like, I'm not sure which form I need to put in first, and you get your references, and so I certainly had questions along the way, but there, I would shoot an email off to Susanna, and I would hear back within, a day or two. So it was quite easy, and I never spent too much time lost. And so yeah, I think there's always someone to help if you have a question, and it's just a matter of reaching out.
Awesome. Fantastic. Well, congratulations on being
Yeah,
one
thank
of our
you.
newest board certified environmental engineers. And thanks for joining this PechaKucha. Thanks for having such fantastic facial hair. I really appreciated you and I having those pictures. You
No
were
competition.
you were such a good sport to do this. Really, thank you so much, Aaron. So, Marissa, we'll turn it over to you to close us up. This is the end of another successful PechaKucha event for the Academy. Thank you all for joining. Marissa.
Yes, thank you everyone for all your questions, and thank you to all of our speakers for sharing your knowledge today. We have several webinars planned in the near future, so you can go to aaees.org/events to reserve your spot. Just a reminder, if you're not yet a member of the Academy and you're considering joining, please email me to discuss our membership options. Last but not least, our PDH certificates for this event will be sent out this week. That's all for now. We enjoyed being with you all today. Thank you so much and have a great day.